Hello students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the terms and definitions for the water technology that includes different terminology and definitions that are used in this module. So first one is the hardness of water. So what is the hardness of water? Hardness of water is the characteristic which prevents the lathering of soap. If you see this picture, the lathering is good here because this water is soft. But lather is not very good or bad here because it has hardness causing salts. So these hardness causing salts will prevent the lathering of the soap. So this is due to presence of salts like calcium, magnesium and other heavy metals that are present. So next is the temporary hardness. So we have two types of hardnesses like temporary hardness and permanent hardness. So we need to understand what is the temporary and permanent hardness. So what are permanent hardness causing salts? So which salts are responsible for temporary hardness? So which salts are responsible for temporary hardness? The temporary hardness causing salts are carbonates and bicarbonates of calcium and magnesium. So if you see the water from the rain is soft in case, but when it is combined with the ground level, it is combining with the calcium and magnesium salts that are present underground. So that is how that is getting contaminated. The rainwater is getting contaminated. So this is nothing but causing hardness to that particular water. So temporary hardness causing salts are nothing but the carbonates and bicarbonates of calcium and magnesium. So next, what are permanent hardness causing salts? So there are two different types. Then the other type is the permanent hardness. So what are the salts that are causing this permanent hardness? So the permanent hardness causing salts are sulfates, nitrates, chlorides of calcium and magnesium. So most widely the calcium and magnesium are present in the water. So the sulfates, chlorides and nitrates are responsible for the permanent hardness causing salts. Then what is degree of hardness? So we have to, like, hardness will be given in the form of a degree of hardness. So this degree of hardness is defined as the amount of hardness causing salt by molecular weight of hardness causing salt into 100. This is like giving in the form of this 100 is multiplied to express in the form of calcium carbonate equivalence. So the best definition for this degree of hardness is the amount of hardness causing salt by molecular weight of the hardness causing salt multiplied to 100. So that will give the hardness, degree of hardness of that particular water in terms of calcium carbonate equivalence. So what are the different units we use? So what are the various units? Parts per million, ppm, that is in shortcut called ppm, milligram per liter, mg per liter, and clerk degree clerk, degree French. So these are the different units that we use for expression of hardness. So if at all, if you want to convert from 1 ppm to degree French, we have to multiply with 0.1. So these are some conversion factors that we will be using. For as of now, for the definitions, you have to write like parts per million are the units used, milligram per liter, degree clerk and degree French. What is complexometric titration method or the complexometric method? So complexometric titration is a form of volumetric analysis. Here we will be taking a burette containing EDTA and we titrate with the hard water. We take here the hard water and titrate. So titrate with this. So there is a color change for this water. So wherein this is because of colored complex formed that indicating the endpoint. So what happens? The calcium ions that are present in the water will combine with the EDTA and form calcium EDTA, and magnesium will form magnesium EDTA. So the Iriochrome black tea or EBT is the indicator we use. So it is wine red in color. Wine red to blue color it forms. It means that Iriochrome black tea is free now. So initially it forms EBT magnesium. So this is that is why it is having wine red color. So when it is titrated with EDTA, it forms magnesium EDTA, calcium EDTA, and the leftover indicator is blue in color. So therefore, the end point is the reaching of blue color. Okay, so this is the complexometric titration method for estimation of hardness. So complexometric titration is a form of volumetric analysis wherein the colored complex is used to indicate the end point of a titration. So next, define degree clerk. So this is a unit that we use for expression of hardness. So the number of grains of calcium carbonate equivalent of hardness causing salt present in 1 gallon of water are also called as number of parts by weight of calcium carbonate equivalents of hardness causing salt present in 70,000 parts of water. So degree clerk is expressed like it is not for a liter, not for a liter. It is for 70,000 parts of water. So the weight of calcium carbonate equivalents of hardness causing salts in 70,000 parts of that water sample. So that is expressed in the form of degree clerk. Then define degree French. So number of parts of by weight of calcium carbonate equivalent of hardness causing salt. So whatever hardness we get for that particular water sample now is expressed in the form of calcium carbonate equivalence. So this calcium carbonate equivalence, when it is present in 105 parts of water, then it is expressed in the form of degree French. So this is the meaning for the degree French unit. Then write the full form of EDTA and EBT. EDTA is ethylene diamine tetraacetic acid. Ethylene diamine. So two ethylene groups and diamine group, two amine groups. So nitrogens will be present and tetraacetic acid. So here we have acetic acid groups. So that is how EDTA is defined and used in the titration. So here we just need to give the full form, that is nothing but ethylene, that is E ethylene, diamine, D diamine, tetraacetic acid, so that is nothing but the EDTA. Eriochrome black tea is nothing but the EBT, eriochrome black tea. So that is nothing but the EBT in short form. Then what is the principle of EDTA titration method? It is like this EDTA binds with the metal ions in water to give stable chelate complex. Chelate complex is nothing but it is forming a complex with the metal complex formation. So hence it is called as a complexometric titration method. So if you see here, the sample solutions have metal ions. So these metal ions, whenever an indicator is added to that, it forms a metal indicator complex. So the metals always have the complexation property. So they form a metal indicator complex here, and upon titration here, we are titrating with EDTA. So EDTA, after titration with EDTA, metal EDTA is forming. So this is the stable, colorless complex and free indicator is colored. So the main principle involving in this method is the formation of a chelate complex. Chelate complexes are formed and therefore it is called as a complexometric titration method. Okay, so why is pH 10 buffer is used in EDTA titration? Why the pH has to be maintained? Because EDTA is insoluble in water at low pH. Low pH is nothing but acidic pH. So it is not, it becomes insoluble in acidic pH. So because H4Y is predominant in the pH less than 2, it means H plus ions are more and it becomes dominant at lower pHs. So with increasing with the pH, each hydrogen in the carboxyl groups of EDTA will start dissociation. So this will get dissociated when there is an increase in the pH. So as we add this Y4 minus to react with the metal ions present in the titration solution, we use pH 10 buffer as such as example is ammonium chloride, ammonium hydroxide mixture. We generally use this mixture in maintaining the pH for the buffering capacity. Then what are the impurities present in water? So what are the impurities present? There are several impurities that are present. So that are like suspended matter, suspension matter, or dissolved substances, colloidal impurities, and organic impurities are widely present in water as impurities. Okay, so these are the different forms of impurities that are present in water, that is causing impurity to that particular water sample. Then what are the disadvantages of ion exchange process? So we have an ion exchange process. This process is used for softening of water, that is like hard water is converted to soft water by exchanging the ions, the cations and the anions using resins. So the ion exchange resins are expensive because they are costly. They are made from styrene and divinyl benzene, for example. So these are expensive in cost. So the cost of purification will also be high. So this is the only disadvantage that the ion exchange process has. Okay. So what is softening of water? So what is really the softening? The process whereby we remove or reduce the hardness of water, irrespective of whether it is temporary or permanent, is termed as softening of water. So temporary contains carbonates, bicarbonates, and permanent contains mostly chlorides, sulfates, nitrates. So these all both will be removed using softening technique. So that is why softening process is widely used to remove any type of hardness. So this process whereby we remove or reduce the hardness of water, irrespective of whether it is temporary or permanent, is termed as softening of water. Then what is potable water? So potable water is nothing but the water that we use it in our daily life. So drinking water is also known as potable water, and the water which human consumption is used is also called as potable water. In other way, it is also called as like human consumption. It is used for the human consumption. Okay. So what is screening? So there are several many steps used in purification of potable water. In that, the first step is the screening. So what does the screening do? We are just screening the water. If you see this, there are waste matter that is being clogged or stopped by this gate. So in the larger dams and river dams and all, we have these screening processes taking place, so that these large number of screens will remove any waste matter like wood or leaves that are present in that particular water. Okay, so the water is passed through screens having large number of holes in it to remove floating materials or floating impurities like wood or leaves. So if you see, they are floating and got stuck here at the gate. So that is how the screening will function and remove the wood or leaves that are floating in that particular water. What is filtration? So filtration helps to remove the colloidal and suspended impurities. If you see here, there are lot of impurities present in the potable water. Potable water are generally purified from lake or rivers that is having a large amount of water. So filtration will help in removing these colloidal and suspended impurities not removed by the sedimentation. So after screening, there is again sedimentation process. If at all it is unable to remove in the sedimentation, the filtration will take the it will favor in removing this the suspended impurities or the colloidal impurities that are missed to remove in the sedimentation step. So what is sedimentation? The water is allowed to stand undisturbed for 21 to 2 to 5 hours. It's not 21, it is 2 to 5 hours in big setting tanks. If you see this, the dams or the lakes will have this type of construction wherein sedimentation is taking place. So they are undisturbed. The water is undisturbed for some time. So undisturbed, that will allow. So as the time is increasing, the sedimentation will happen. That is, the height is reducing. It means the molecules are coming to this extent, or the particles that is sedimenting to the bottom of that particular reservoir. Okay, so what is chlorination? The process of applying a calculated amount of chlorine to water in order to kill pathogenic bacteria is called chlorination. It means that a chlorine in a certain amount is added to water to remove pathogenic bacteria. So this pathogenic bacteria will cause diseases to the humans when it is consuming, when the water is consumed. So for that, to avoid chlorination is done prior we use it for any of the purpose. So that is the process of chlorination. Next, what is breakpoint chlorination? So the amount of chlorine required to kill bacteria and to remove organic matter is called as breakpoint chlorination. So this is the graph that we get for the breakpoint chlorination. So this is the breakpoint chlorination. We keep on adding the chlorine here, and if we see the iron, manganese nitrate and trihalomethanes are forming, monochloromethanes are forming, and many other chloramines are forming. It means the organic matter is break down into different compounds and they get removed in these forms like chloramines and monochloramines or trichlorohalogens. So whenever it is like combining with it, the amount of chlorine, residual chlorine is high. It is high. So if there is a drop and there is again very high increase in the residual chlorine, it means there is no more organic matter to be removed or to be reacted with this chlorine. So therefore the residual chlorine concentration will increase. This is how a breakpoint chlorination is determined from any of the process in the chlorination step. Next, what is ozonization? So ozonization is like ozone is used in the removal of any of the matter or disinfecting this particular water. So in this method, ozone is passed into the water which acts as disinfectant, and ozone is unstable isotope of oxygen. So ozone is O3, so that will give rise to O2 plus nascent oxygen. This is O. Nascent oxygen. So this is highly reactive. This is highly reactive because it is not stable. So it is highly reactive, therefore that works as a powerful disinfectant. So in this method, what happens? Ozone is passed into the water which acts as disinfectant, and ozone is unstable isotope of oxygen. So this is unstable at any cost. It will be converting into oxygen and nascent oxygen. So this nascent oxygen is used as powerful disinfectant. So this is how it will remove harmful metals like iron, bacteria, virus, manganese or hydrogen sulfide present because of feces and other organic matter. So what is coagulant? So there is a process called as coagulation used in purification of potable water. So in that we will be using some compounds or the chemical compounds called coagulants. So coagulants are substances which cause particles in liquid to curdle and clot together. So whenever there are impurities like this, when the coagulant is added, there is a trapping. These coagulants will form curd like things, like they will form lumps and they get settled down. When the suspended particles are combining with the coagulant, they increase in the size and the weight will increase. Therefore, helps in sedimentation, helps in precipitation or sedimentation. This is how the coagulant will help. So coagulants are substances which cause particles to in a liquid to curdle and clot together. Define deionized water. So what is the deionized? D is removal, ionized is ions. We remove ions. So that is nothing but the deionized water. Water coming out from the exchange is free from cations as well as anions. Ion exchange is free from cations and anions. Ion-free water is known as deionized water or demineralized water. If you see this picture, it is very clear. Like if this after going to this area, it is like no more ions are present. And very less will be present. So that is nothing but the deionized water. Name any two coagulants. So I have said that coagulants will help in curdles and forming the curdles and clotting. So these coagulants is nothing but the chemicals that are used. So examples are alum, sodium aluminate, and salts of iron. So this is the alum that is present. So the chemical compositions: aluminium sulfate, hydrated aluminium sulfate, ferric sulfate or ferric chloride, that are most widely used for the coagulation processes.
Like, share and subscribe. Hit the bell icon for more updates.